Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you are amongst the 50% of the people who have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. And most importantly, if you would like to join the debate, there is a link in the info box below this video. With the page you are currently listening to me on muted, simply click that link to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number one, please do not swear. If you do, you will be ejected. And if you are, please do not try to rejoin the stream using sock accounts. You will be warmly welcome back on the next stream. Now in a moment I'm going to transition across to my photos so I can share the show on Facebook, Skype and Twitter, and I would encourage anybody who is currently in the live stream to please also do the same. Please share the show. Sharing the show increases the live audience, which in turn increases the diversity of the people on the panel. So sharing is very important. Please share the show. And one last time, if you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Let's see if I can do a few shout outs while I'm doing this. Shell Scanner, 33rd. Good to have you here, Shell Scanner. Sorry I didn't shout you out for your super chat yesterday. Too much conversation going on, but I did thank you in the chat. But thank you very much all the same. Alex Quant, thank you for being here. Nice to see you, my friend. Good to have you. The Rig says yo yo, everyone. Yo yo to you too, The Rig. Flat Earth Hippie Chick, nice to see you. Good to have you here. Ashley Brown, nice to have you in our live stream. Thank you for being here. If one of you could just click that link just to check that the live stream does actually work while I'm doing these shout outs, I would be extremely grateful. Veen, thank you for being here. Nice to see you. Nathan seems to have some sort of strange alien sitting next to him. No, that's my daughter. Excuse me. Jeff, good to have you here. Nice to see you, my friend. Badge. Hope I've said that right. Good to have you. Nice to see you. John Watson, thanks for being in our live stream, John. Nice to see you as always. Good to have you here. Rob S, thanks for being here. I think that's pretty much it. Oh no, Boss Ute. Good to have you here, Boss Ute. That's pretty much it for shout outs. We do tend to get guests a lot sooner on these shows since I've done about 76 shows. We get guests a lot quicker, so I'm going to do my links now because I probably won't get an opportunity in 2 or 3 minutes when someone joins. So, if you are new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live, so if you're enjoying these live streams, toss me a buck or two in the super chat. And most importantly, if you would like to join the debate, there is a link in the info box below this video. Simply mute the page you are currently listening to this message on, then click that link to join the discussion and express your views on the shape of the Earth. Please do not swear. If you do, you'll be ejected, and if you are, please do not try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. One more time, if you've not done so already, please share this stream on social media, and if you've not subscribed, subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. You may hear from me one more time if we're not joined by our first guest in the next 10 or so minutes. If we are, I will introduce our first guest. Flat Al, good to have you here. Our comedian eye, good to have you here as well. Rune Thornton, good to see you. Any more for any more? Nope, I think that's it. No one's tested the stream yet. Has somebody tried and failed? Because if so, I need to get on the case and get a new link in there. Just let me know in the chat if somebody has tried to get in but couldn't. Alex Quant says 4-1. Anthony is the first guest. My money's on curved water. And we've been joined by Make4. Good to have you here, Make4. Nice to see you.
What's happening?
One more time.
What is happening?
Oh, I can hear you now. Brilliant. It's just me with the hangout lowered. Let's just transition across. We've also been joined by... Is it the Rig? The Rig!
Hello?
Good to see you. How are you doing, the
Hey.
Rig?
Yeah, not bad. Yourself?
Very well indeed. Thanks for being here.
No worries.
Good stuff. I don't know if you were joining just to check the hangout was working or if you wanted to have the platform to spout your rhetoric. Either way, feel free.
I was just gonna wait for people to come in here and start talking stuff and see what they had to say, see how they feel about Banana Earth. I'm waiting for Riley. We can talk about the Curie temperature of iron, or gravity, or the vacuum. See, I think we should just go for the top 3 arguments, which is pretty much gravity, vacuum, and what was the other one? Like constellations not moving. There you go, top 3 arguments. What have you got now, scientists? Oh, you're tutted.
Jamie Woodstock says, what's with the pictures? Well, the trouble is that if somebody joins and I don't know who they are, they could do what they like. They could display something that they shouldn't be. So I need to have a facility to put something else on the screen that's not the hangout, and that's pictures. So the more naughty the guests are, the more likelihood the audience is just going to get pictures, because that's what I put up when there's kerfuffle.
Yeah, I left the chat, so I'm not really reading that chat, but...
If I wasn't hosting the show, I probably wouldn't read the chat.
Oh, it's full of crap, honestly. It's,
so toxic.
just... Oh, they talk about your wife and stuff in there, buddy. Does that feel good?
The
Couldn't care
chat is
less.
awesome, Make4. Come on, mate. Come on.
You're always there, just talking.
That's where the action is, mate. It's where the action is.
I mean, I get it. I get that people like the chat, but you know, there's sometimes a friend of mine will come in there and you'll go, "Oh God, don't stay in the chat," because obviously everyone just descends on people like Patricia or whoever, and just gives her a load of grief in my chat. And I'm not going to ban anybody for doing that. I mean, there's a few things, not that I'm going to mention on air what they are, but there's a few things that I will ban people for. Very, very few, admittedly.
God, you've let a lot go.
Yeah, I don't care. You know, people pretending to be my wife or saying stuff about that, I don't care. Literally couldn't care less.
Been good.
Just shows the type of people we're dealing with in this arena, though. That's why I have it on screen. I've said this many times. You know, the reason it's on screen is so that people who watch this back at a later date get to see the kind of crap we deal with in this corner of the internet. And it's pretty unique. I don't want to say it's totally unique. I'm sure there are other areas of the internet that get trolled as badly, maybe. Not that I've seen them. This is the worst. Literally, as far as chats go, Flat Earth is the pits.
It's hilarious. Yeah, it's pretty crazy. But yeah, like myself studying flat Earth after someone mentioned it to me and sort of made me second guess life and who I was. I don't know, it's kind of stressful, to be honest. Like, I wish we could all just come together and figure this out, because even me in the last week or so, whatever it's been, I didn't actually talk to anyone really about it because I thought it was really weird. Like, and most people, when you bring it up with most people, they're like, "Get the fuck, sorry, get out of here," is what they say. And it's, you know, you can't you can't have a valid conversation with most people in your day-to-day life about that kind of thing. They're just like, no, you're weird. Stop. Don't even talk to me. Okay. Like, so that's what my friends are like sometimes. They're just like, no, look, Marcus, it's not, you're being stupid. Like, they're just so stubborn. And I'm like, oh, okay. But coming in the last, like, finally I've came into these live chat room sort of things and had a chat to people about it, and sort of I'm trying to basically debunk it, I could say. That's what everyone always says. And like, I'm just going through these points of about what people say and listening to what they say, and okay, figuring it out. And personally, I feel like the sky to me is does kind of show that we are on a globe. I think, like, but the other thing is, like, like, the whole space trickery, like, we've never been, and then you don't see stars up there apparently, or you do, you don't, who knows. And then it's like all the magicalness of things working together, such as gravity and whatnot, like, and just keeping us perfectly here day to day, no worries. Like, it's pretty magical, really. And it's like something just doesn't add up. Like, where I'm seeing the spherical sky, but I'm seeing videos of drones going up and just giving me flat. Like, I can see for miles flat. And then weather balloons even more so, depending on what camera you have. But, like, yeah, and I mean, the arguments are crazy. Like, we're talking about gravity and stuff. Oh, well, I know how it works because it's exactly this much force of pull on it, and this much speed, and this orbit, and this axis, and, like, it's definitely doing that for sure, 100%. I'll give you footage. Here's footage. Here's the moon going behind Earth. Like, no, doesn't really happen. It's not like turn around in your space shuttle and give us views of the rest of the cockpit and stuff, and they do that, and it's dodgy and blah blah blah, and it's military, and it's a big secret, and technology and stuff, and we're in a race, I guess. But it's doing people's heads in, man. Like, some people I hear, honestly, use a spaced out hardcore, like, and I was as well. And I think it's not really helping anyone arguing the way we are. Well, it's good sometimes, but am I still here talking?
Yeah, I'm listening. My favourite part of those conversations are where they do exactly that. They explain how gravity works and all the forces involved, and then they go on to explain how you can't feel or experience any of it. Same with the speeds.
Right.
Yeah, we're going at this
Right,
ridiculous
see-
rate through space, but you can't actually tell. But that's all good.
Yeah,
That works.
Yeah,
You're not
that is
supposed
a
to be
very
able to
weak
tell.
argument, and like, that kind of argument, I would say, is almost like, okay, if it was relativity and we wouldn't notice it or whatever, like, fair enough. Okay, good on you, you got that one. But, like, yeah, we don't really feel it. I'm personally on the I don't feel it or see it side, because, like, every night the Milky Way goes round. Like, it doesn't change. Constellations don't change. We never see behind a constellation, or, like, we never move around a constellation. They're so far away, right? But, like, they would be shifting like that, like twisting and turning in their little space areas, and going different directions and stuff. Like, uh, but yeah. So anyway, what my point is, like, the thing is that some of the globe stuff is actually on point. Like, I do get a globe model when I look at our sunrises and sets all over the world, and how they're the analemma, whatever it is, and how it shifts. If you look at that closely, and how you would see the sun doing that, like, you do get a globe model out of that, which trips me out because I don't feel like I'm on a globe. I'm not, like, it feels
Like, what
yeah.
about the sun setting in the southwest and rising in the southeast and that? Like, it doesn't
Yeah,
work on
that's what I
on a
meant.
flat. That's
Yeah,
what stuff.
exactly.
So,
Like, that there gives you the axis as well. If you look at it, you'll see when we're coming around the globe on an axis, tilting a little bit as well, it puts your north, south, east, west off, and then the sun starts coming up at southeast, or for our summer, for Australia's summer. and yeah, anyway, and it also gives you the bit of the distance. Like, as I have to, I'm really siding with the Globers here. Sorry, but like,
No,
it gives you,
it goes
yeah, it gives you,
against the map. You know, it goes against
yeah,
the
it
AM.
does, it does, and it gives you the distance because like everyone in when it's summer for the southern hemisphere, the sun always rises and sets in the southeast and southwest, and then when it's summer for the northern guys, it rises and sets in the northeast and northwest. So that if you look at that and figure that out with your head, do it on a globe, like you'll see like holy shit, it is actually on an axis, and it's that axis that causes that. And like if you look at that, like then the sunrises and sunsets of flat Earth would mean it would be like doing a little wave like around by us. Oh, it's hard to explain, but anyway, the thing is that could all just be big like this is where the argument comes down to it. It's like, okay, that's a massive giant gas ball that's held together by gravity, and then someone else goes, no, that's a magical mirror in the sky that's controlled by God, and or some other weird idea. Like, and that's the point that I think we're at the moment. Like when it comes down to these arguments, it's really out there stuff where no one can really say for sure, like, well, we do have spaceships on there on those like things for sure, 100%. Like, until we see something like that, and I've got dudes live on camera going, guys, I'm on Saturn, or not on Saturn, but like here's Saturn live kind of thing. That would be nicer.
Been joined by Arev. How you doing? Good to have you here.
Good. Hey, how you
Good to,
doing?
good to see you. Thanks for being here.
Oh, pleasure.
Really close as well. I want to see those Saturn dust rocks smashing around, like I keep telling you guys. You know, should be real time almost because it's close enough, right? Or does it take 8 minutes? Sorry, the radio delay. And we can send those things to Mars and radio delay control that stuff and land it somehow with like a 20-minute or 4 to 20-minute delay. Okay, and it's traveling how fast? Through the solar system. Okay. It's a little bit out there. I'm talking a lot. Sorry, guys.
Oh, no, it's good. I was just gonna say you can see the sun rising and setting in the southeast if, the circle of the moving sun just clips the range of your vision. I mean, people still have a limited range of vision, and so they're only gonna see so much of the sky. Maybe the circle of the sun is just clipping the I guess it would be southeast, so what it would be like the lower left quadrant of your
Yeah,
vision. But
I see what
that's
you're
to
saying.
model it
Like,
like
that's why I was saying,
you'd have
like,
to model it like
you can say just about anything, like, oh, it's the dome causing a weird
well,
refraction or something. Like,
well, rainbows are only explicable with the dome over our heads. There are videos of objects hitting the dome, and then you kind of hear science kind of dancing around the issue, saying we can bounce signals off the ionosphere. Maybe they're talking about the dome and they're just lying. So there's
what
something
if?
up there.
Okay, I accept what you're saying, and like, I just with where I was going with my sort of talk about the weird circular sky and how it does come out as though we are on a globe. What if like it was some kind of just what if like space actually was impossible and like it was sort of some illusion sky that you could just never really get to because I don't know if you like if it is actually some sort of god situation or whatever, like would he have like designed this place and then just been like, oh, I'll also design all these other like hell far away places that no one can really get to at the start, but then later they'll get to it because they want to get out of this place. Like, what? But why? Like, if you design this place in the first place, why would you want them getting out? You'd make it like you'd want them to enjoy it and like take care of it a bit more. I think, like, which is where the circular sky kills me because when I see photos of a flat beach and boats coming back over the horizon and mirroring on the horizon, and then the sun getting smaller at sunset sometimes and trips me out. Maybe it's the camera. It's so rah rah rah. Like it doesn't match up. So I feel like it's flat, but it's circular, and I'm so torn. And then I look into weird stuff like that Freemason like compass and square, where they've got the compass on top, which is like circular, and the square on the bottom, like it's flat. I looked into a bit of that, and people have dug into that sort of thing. I don't know, man. That's my weird idea, and that's where I'm stuck right now. And I think a lot of people are sort of feeling that as well.
Well, don't most people say something like we're on a flat plane that is not moving through space? It is geostationary and still with the sun and moon orbiting around us, and we're covered by a circular dome. I mean, I guess in that way it is circular, but we're not a globe spinning through space. Gravity is a deception. It's not necessary since we are still an unmoving. Density, magnetism, and buoyancy take you down, scientific paths that are reasonable, factual, and valid scientifically, and take away this boondoggle of science that requires all of these band-aids like dark matter, and all these things to fill in the holes in these terrible calculations. I mean, there are just too many assumptions on the gravity side of things when, experiment after experiment has shown that we are not moving. So maybe
Yeah,
we're on a flat plane with a circular dome or whatever.
one thing that weirds me out is the globe model. They claim the moon to be off by 5 degrees or whatever it is, and then we're on this axis as well, and like it's almost like there are forces there pulling us into that axis, or we've been pulled to that position over time. Like, it doesn't really make sense to me. If like I look at this, I've got this little app on my phone which you can like look at the sky and get the constellations, and you can speed up time, and you can make time go by and like watch the sun move. It's called Star Walk 2. It's pretty good, and like you speed up the time and watch the sun move like south to north on the, like, say you're looking west, and you'll see it like just going whoop whoop whoop, like left and right, left and right. But while that's going left and right, the stars in the background don't change. Like, which is fair enough, they're really far away, but like compared to our sun, I guess. But um it's that wavy sun is caused by the freaking axis, isn't it? Yeah, the axis tilt. So why, I feel yeah, man, I just feel like the stars we see in the constellations out there should be moving differently, and and Venus would get bigger as it came towards us in its orbit, and the light would get hell crazy bright. And they probably claim that it probably does, man. I don't even know. Like, we need an astronomer in here or something. But
Well, I mean, they came from the perspective that we're all revolving in elliptical orbits, but that's fallacious in itself because we're not moving, and also we're not a planet like the others. We're on a firm plane that is made for us to live on without, going topsy turvy, going in each and every direction. While the lights in the sky that we call the wandering lights of the planets are of a totally different nature. We're not like them. We're not moving. And so, we're starting from some bad assumptions that we're like these other wandering stars when we're not. And so, no elliptical orbit. Those calculations go totally out the door, and they need to start from a totally different starting point.
well, I'm sure they have maps of the orbits. Like, I'm pretty like, and that damn,
Yeah,
they
they
reckon
do, and it explains the retrograde and everything. Like,
retrograde. Yeah.
yeah. So
Um.
it's pretty hard to go against all that stuff. You can't just say like the other guy just said, throw it out the window. I mean, that's just ridiculous. But yeah.
The only thing that is weird about it is that it just lasts for so long, and but yeah, like this retrograde stuff. Like, if they've got stuff like that that's been mapped by that was back in like Tycho Brahe or whatever his name sort of days, like Kepler sort of days, and like that was weird because that guy was geocentric, and apparently like Kepler was his apprentice or whatever, and then the other dude died and whatever, and Kepler carried on his work, which was a bit sketchy and weird in there. But that
But
could
you
be
hear
twisted.
about these guys, and some of them were Freemason, some of them were believed in magic and stuff like that. Like some of these have occult origins for their models. And so you might have a thing where you have magicians and dark occultists trying to fit models to their occult beliefs and stuff. And that's where it gets really weird. Does this stuff,
Alchemists.
is this stuff valid? But we don't see wild star paths, going back and forth through space like we're supposed to be. I mean, it's just there's things with the model that just don't make sense.
It's alchemy.
Yeah,
Alchemists, not magicians. But yeah, with Tycho Brahe, my understanding was that his objection was reverse engineered. In other words, he went, well, the stars would have to be enormous. And then they reverse engineered it.
Right. Yeah, right. Yeah, pretty much. But it's weird. It's weird. We have the solar system. They're just close, and then after the solar system is the 12 horoscope, whatever they are, constellations that are around the edges, and we just circle that for eternity. Like, I don't know. Cool.
Did you make forward? Did you see the last debate? Did you see what Rumpus his presentation on trigonometry?
Kind of. I remember the last one was Riley getting down with some angles and stuff and trying to figure out the ISS, wasn't it? That, or was I? Did I miss one?
The last one they were talking about the distance to the sun and all that sort of stuff, and how it doesn't work when you calculate it on a flat Earth. The angles don't cross over at a single point, giving you a distance and all that sort of jazz. So it works on a spherical Earth because
That didn't get shown, the rig. Just to point that out. Sorry to cut you off, but they said it worked on a spherical model, but then they showed us 30 seconds of an animation that started to zoom out with all the lines from Earth, but we never got to see them converge on the sun. And when I pointed this out, they went, it's way too big to be able to show visually. And you're like, what a load of nonsense. We have the technology, we have a zoom. We can show it, but they didn't. So we have no way of confirming. If someone else models out Sly Sparkane's model and shows that they all converge on the sun, obviously I'll eat my words, but we didn't see that. We did not see that. They just asserted that that's what happened and then never showed it.
Yeah, I could see your point to that. I thought it was quite funny, actually. It was quite comical.
But what's the problem? Sorry, is it's like the distance is so great and the angle is so acute.
Well, I saw two problems. The problem was Sly Sparkane showed us a video that he gathered data from people who took sticks and shadows and measured the angle to the sun from different parts across the plane, and then he showed their angles. Now, having tracked the sun and done this live so that people could verify that they were actually doing it at the correct time, I know from personal experience that people get it wrong, often get it wrong. So, that was pointed out by Anthony Riley and then completely ignored. Oh no, it couldn't just be human error. But like I say, when we actually get to the bit where it comes to showing it working on the spherical model, we didn't get to see that. We just got told that it doesn't work on the flat Earth model. Here's why. My assertion is that the maths, regardless if it's from 3 points or 2, inserts the presupposition that we're on a spherical model. And you have to adjust the figures to account for that. Whereas if you could do the exact same measurements using flat trigonometry, you'd come out with a different measurement, but it wouldn't suddenly not work.
I mean, could we just humor the flat Earth side by, taking the flat Earth math from a flat Earth paradigm, be like, okay, believe it's round or flat or whatever, but try the numbers from a flat Earth model where the sun and moon are moving instead of us. What sort of figures do you get when you come up with that?
We have that already. That's the geocentric model.
Yeah. And maybe we could see if that matches reality a bit more, because some of this stuff, just doesn't match up. I mean, they say that, they have the diameter of the Earth at what, 8,000 kilometers or whatever, 8,000 miles for the diameter of the Earth. Yeah, but you can go down to Antarctica, and Antarctic explorers have clocked the Antarctic ring at 58,000 miles. So right there, you have a problem. Either these explorers are wildly off, or there's more land than we even think. The planet is even bigger than we think, and those calculations need to be thrown out.
Yes. So, where's Stephen Hawking at when you need him? And why doesn't someone like Stephen Hawking, like or Neil deGrasse Tyson, come out and just be like, "Look, we're having a massive flat Earth debate. I'm going to prove these 100 points wrong to you now," and just be like, "Bam, bam, 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 done, 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 skis, and see you later." And that's how it is.
Mate, have you seen Stephen Hawking's Guide to the Universe?
Probably. Yeah, I've seen a few of those docos.
If you've seen that, he explains how the constellations have moved and where they've sort of moved from,
Yeah,
where
I
the
know.
center of expansion is. So maybe
Hey.
go back and watch that one again, man.
But wait, I did.
Before you
say
get into the
that.
strangle dangle, sorry, we've been joined by Miles. How you doing, Miles? Good to have you here.
Good morning.
Good to see you.
Yeah.
I already agreed it was spherical on the top, and anything could be going on there. Really, like anything magical. So I'm interested now in how people think that it's flat, and the only thing I can see is drone footage and weather balloons, and you have to go through a few of them. And I don't know the Chicago skyline. Like, what is the curvature calculation correct or not?
None of them show anything other than curvature. None of them show it's flat at all.
Yeah, if it's
like
flat, you get infinite plane society. But if it's enclosed, then you have a dome enclosed system, and a dome enclosed system is seen in nature. You can take a terrarium and put a plant in there, and it'll, live basically for it looks like for years, if not forever. I think the longest lived terrarium right now is like 30, 40 years old. And so it looks like the plants grow, make oxygen, die, feed off their own decaying matter, and just keep making oxygen. And so anything theoretically inside of that enclosed system that doesn't use up all the oxygen, aka us, could probably live forever as long as those plants are providing the oxygen and stuff. So enclosed systems could work as long as they're balanced, I guess.
I don't understand how there would be a vacuum with just gases in between it.
Yeah, and you never see that doesn't have some barrier sucking all the gas out. Scientists don't explain to you, well, why the heck isn't everything on
Vacuums
Earth
don't
sucked out into
suck.
space?
Vacuums don't suck.
Well, you kind of need a steel door to hold
No, you don't.
Earth's pressure. Yeah.
Yeah.
Well, I get what you mean by it not sucking actively, but there's an equilibrium that tries to be established between all the gas being in one area and no gas, no matter being in this other area. So equilibrium will try to rush and flow into the vacuum. Typically.
Yeah, but the gas that surrounds the Earth and atmospheres on other planets is held near to the planet by gravity.
There it is, gravity. Gravity, but slinkies can fight gravity. You drop a slinky, it drops top first, then the bottom, which goes against gravity itself.
No, it doesn't. If you examine the forces that are occurring on that slinky, it behaves exactly correctly. You can't isolate gravity from all the other forces. That's why helium balloons will float upwards, because the buoyancy force is greater than the gravity force. It's very simple.
Well, I mean, another error with gravity is able to pull in all of this massive, heavy land, but the air, which would, I guess, theoretically be lighter and easier for gravity to overcome, is further away than the land. Wouldn't the land be harder to pull in than the air? Wouldn't gravity order like what? Air on the inner core of the gravity with land on the outside. It doesn't make any sense. I mean, why is gravity sometimes able to overcome some things, not able to overcome other things? It is extremely inconsistent. And then we make these mathematical tricks.
Consistent. Absolutely consistent. The maths that applies works out every single time. It's not that there's any problem. The more massive an object is, the greater the gravitational force. So if you've got two objects, one is a rock and the other one is something the size of the Earth, that's going to the gravitational attraction between those two objects is far greater than an air molecule and the Earth. It's not difficult. It's not difficult to understand this stuff if you think about it.
But the thing is, then water should have a convex curve on the top. And then, you don't see curved water.
Yes,
water
you do.
always levels out.
No, it doesn't.
We
No, it doesn't.
see curved water that is curved by gravity in oceans. When have you seen a frozen lake that has a frozen curved surface? How would they walk from Siberia to America without slipping down on this curve? On this curved water that curves 8 inches for every mile after you square the miles.
Look at my avatar down at the bottom. Look at my the picture. Okay, that's curved water for you. All the water, all the lakes, all the oceans, all the seas. It's all curved.
All suffers atmospheric refraction.
It's demonstrably so. So just live with it. That's
wonderful
that's
demonstration
what it looks
of
like.
atmospheric conditions. Lovely.
Sorry?
Atmospheric conditions.
Absolutely nothing to do with atmospheric conditions, Nathan.
Everything to do with atmospheric conditions.
And you have absolutely no evidence that it is anything to do with atmospheric conditions.
Other than the millions of demonstrations of atmospheric conditions that occur.
Sorry?
I've seen
Other than the millions and millions of demonstrations of atmospheric occurrences.
Millions?
Yeah.
Millions?
Yeah, daily.
Well, you should be able to find one then.
Daily. Literally, you could go out with a camera and take a picture of one today. Riley does it all the time. Takes pictures of atmospheric.
No, he doesn't. Riley has
atmospheric
proved
interferences
the curve multiple times. He consistently does it. Every single piece of evidence Riley ever produces shows the curve. There is no evidence that atmospheric conditions are the cause of what Soundly and others see at Lake Pontchartrain. There is no evidence that atmospheric conditions cause any of the effects that we see over water, but there is proof that it's curved. Absolutely. Well,
yeah,
proof,
atmospheric
I say.
conditions do
Loads
occur.
of
Anyway,
evidence.
we've been joined by Anthony Riley. How you doing, Sleeping Warrior? Good to have you here.
Just thought I'd have to step in and correct this garbage that's coming out of thingy Miles's mouth. I have never once collected evidence of the curvature. I have
every video.
Where's
the bottle of
bending
bottom of
light.
Blackpool Tower? Why couldn't you see Ireland from St Bees?
I could, Miles. You're the one that dishonestly ignored and interpreted the evidence to suit your premise.
Not at all. You saw
Absolutely.
the Isle of Man. And
absolutely, Miles. You were
couldn't
dishonest
see
with
the
your
bottom of Blackpool
interpretation.
Tower. Why
And
not?
when you were corrected, Miles, you simply would not accept it. So I left your discussion.
You ran away because you had nothing.
No, because you were being dishonest,
Absolutely
Miles.
nothing.
You were being dishonest.
Do you want to go back and look at it?
Absolutely. Let's do it. Play it now.
Well, can't we just do it over and just start with the footage again? Wouldn't that make more sense rather than analysing what's been said over?
The important bit is how Miles interprets the.
I would like someone to show me something that shows the Earth is flat. Anything.
Oh, we're going to do that right now, Miles.
Come on then, show me the Earth's flat.
And we will quote expose your dishonesty. So let the people
show the Earth is flat. Go on.
Let's. How do we play? Should I play it or Nathan play it? I'll play it. Just hang on a sec. I'm just trying to finish off a task before I come on. That doesn't appear to be working.
The best stuff is drone footage on YouTube, and you
give me one sec
and check it out.
Like the drone footage that shows the sun setting, and then the drone moves up higher, and you see it setting again, and it goes up higher, and you see it setting again.
Okay,
that's good drone footage.
Okay. Check it out for yourself, and I don't know. See how you want to look at the light of the sun and like the shadows that it's putting off, and how close it really looks, but maybe it's not.
It's not.
And what kind of camera it is, and if the horizon bends because of a fisheye, and how it bends.
How far away is Mercury, the planet Mercury?
Well, that's a funny one because you should look that up on. Oh, hang on, isn't it like 50,000? No, 50 million kilometers.
It's a long way, yeah, and it's verified by radar and by we've sent spacecraft to Mercury, and based on that calculation, and they've traveled that distance. Mercury passes between the Earth and the Sun. It's been photographed passing between the Earth and the Sun, so the Sun must be further away than Mercury.
Well, you can see Mercury and Venus at night. Mercury and Venus are closer than we are to the sun, and if they were following circular paths, they would be in an inner circle that's closer to the sun. Therefore, we'd only see them when we're facing the sun. We'd only see them during the daytime. How do we see it in nighttime when we're facing out into space, in the blackness of space, away from the sun and away from the circular orbits that Venus and Mercury make? Some of this stuff still doesn't make any sense. We should only see Mercury and Venus during the day.
That's nonsense.
Let's talk about a little bit more nonsense. Nathan, would you present my screen?
Yeah, you're up. You've just stopped sharing though for some reason. Oh, there we go.
Right, for the benefit of the people in chat. Oh, and by the way, Alex Quaint, you shouldn't take up betting because I've seen your odds that you were presenting for me to appear, and they weren't good enough. Otherwise, I'd have been in. But anyway, the point of this now isn't necessarily to discuss the content of the video. It's to discuss the accuracy and the validity and the honesty that Miles has in interpreting this evidence. Okay, so that's the focus that we're going to look at. Let's play and let's see where Miles takes this, because it's going to go somewhere really rather interesting, and it's going to put Miles into context with regards to his gish galloping nonsense that he talks. So I will pull up Google Earth and I will present my position on this, and then Miles can say his position on this, and then we can laugh at Miles with how ridiculous his is. And this would explain why I didn't stick around in the chat with Miles, because he was simply being dishonest. There is no other word for it, and I'm going to demonstrate it with you all right now. This is where I took the photos from. And I'm going to just get the distance so that people are aware. Come on. There we go. And Miles was saying that it was somewhere. I can't remember how I did this now. The issue was Miles found. Right. Okay. I'm on it. I need the Magic Maths Bendy website stuff. So this would be. There we go. Right. So I was 34 miles away. And I was 34 feet off the floor.
No, you weren't. You were much higher than that.
Oh, you tell me the figure that you're happy with.
We don't know the height, but let's because the tide was out, and we don't know exactly what the tidal conditions were at the time.
Make something up that you're happy with.
Let's go for we're plucking figures out the sky, okay? But let's go for 60 feet.
Okay. 60 feet gives us a refracted hidden distance of 322. So that's the figure height that we're looking for on the landmass that Miles thinks is Isle of Man. Now, the conversation got to this point. I'm using my tool to work out the elevation of the land.
I'm not seeing your calculation there. So your screen seems to have frozen on that bit. It's moved now, but
it's all good this end. Audience are getting it okay.
So I'm looking for an elevation point of around about 340. Well, anything beginning with 3. As I'm moving my mouse up and down this area that Miles says that I'm in, or that I'm witnessing, there's not really anything that's.
Can I interrupt briefly, because you not only have to add the height of the tide and things to your location, you also have to add it to the height on the opposite side. So that's the height of the mountains as well.
Oh, do you? So basically, this is the position when Miles starts becoming a little bit crazy, because nobody's ever told us this maths before. Nobody's ever said we have to add height to the land that we're on the other side.
Yeah, I've never heard that. Can you just so we get it for this feed, can you just repeat it in full, Miles?
It's very simple. You're simply taking the curve and you're because the tide is out, basically the curved part of the Earth is dropping down relative to you, but it also drops down relative to the objects on the opposite side. So if you take into account the actual level of the water rather than some standard average sea level, then you need to add the number that you use for your observer height. You also need to add that to the height of the objects that you're observing.
Right, let's just go with it.
Well,
Miles, what figure do you want me to add?
It's straight maths.
Where have you got this?
Now,
where have you got this from?
The other thing,
Miles?
Anthony, is do you have
Sorry,
a
just
measure
before we move
for
on
the
from
amount
this point, Miles? Sorry,
the
trying to know
amount
where
of
you've got that
refraction
from.
that would have been
Sorry,
occurring on
Miles,
that day?
Miles. Where have you got that from? Where's citation is needed? What have you? Where have you got that information?
No, it's not needed. No, it's not needed. That is a simple geometric fact.
So just a geometric fact that you're asserting and no one else ever has ever.
It's a simple geometric fact. If you want to present some geometry that shows I'm wrong, go ahead.
Would you show me in a geometry textbook?
Take a
This is
circle.
a geometric fact, Miles.
Okay.
It should be easy to find a
Take
reference
circle.
for it. It's a geometric
take a line.
fact. It'll be
Okay,
easy to find, won't it?
I'll present it. No, I can't present it on this computer. Sorry. You're effectively extending the line above the circle.
I don't want you to detail it again, Miles. Miles, I don't want you to detail it again. It's okay. What I want you to do is provide a citation. Show me it in a textbook or anywhere.
Nathan, if you want to say that is wrong, then by all means say that it's wrong. Show me that it's wrong.
I'm asking you to provide a citation for it rather than just stating it as fact.
Well, I don't have one to hand.
Okay.
But and I can show the geometry, but I can't do it on the computer that I have at the moment because it doesn't have an appropriate program on it for doing it.
I think he's talking about this. Are you talking about seeing over the curve?
Yeah. So if the water level is lower, then you have effectively added height to both the object on the left and the object on the right. You've not just added height to the object on the left. It's very, very simple geometry. It's gone awfully quiet.
Yeah, like this is the thing though, right? Because this horizon that's in front of us, like I've seen boats on the horizon just at the point where they're about to go over. Behind that is nothing else because he's gone over, and there shouldn't be anything else really behind it. But then I've seen photos where it looks like that, and then you see off in the distance behind him a building, like just sitting there.
But you can see across. You can see above that. You can see, tall things beyond the horizon. Parts of them are still visible. That's why Anthony could see Blackpool Tower.
This one I could almost like see the base of the building. It was weird. I actually don't have that photo anymore. It was ISA that showed me that one. Anyway.
And you can get refraction effects and mirage effects that do all sorts of things.
So where are we at? Are we adding more height to it, or are we?
Sorry to interrupt. We've been joined by Paul. How you doing, Paul? Good to have you here.
Oh no.
Yeah, just home from a presentation evening, so yeah, far enough.
There's something wrong with your text in the chat for some reason. I don't know if it's because you're in Australia, but it was upside down for me, just so you know.
Yeah, I'm in Australia. Everything's upside down here.
Yeah, just wanted to make you aware of that.
Paul, explain gravity right now. Oh my God, go.
No, but I'd concur with Miles. It's a simple. We don't need a citation for that. If you're standing on a bridge that goes over water and the tide drops, is the surface of that bridge higher above the water level or not? It's a simple question. Of course it's higher above the water level.
Nathan,
we don't need textbooks to tell us that.
Let's just give it them, Nathan. They can have us whatever height that they want because the demonstration comes with the interpretation of the evidence against the maths, not the maths, the geography of Google Earth. So we'll just give them whatever height they want. Miles, what height would you like?
What do you mean? What height would I like?
Well, you've got it.
It's really not a question of what I like or don't like.
It is because you make it what you want. So we'll give you whatever height you want. I want to get to the point where we can interpret your interpretation of the evidence and show how dishonest you are. So pick a height, Miles.
For what?
The observer height, we were at 34 miles, and we were at 60 miles, was it? Sorry, 60 feet. Should we give you
your observer height could be you were on a hill that is something like 35 feet above average sea level.
Miles.
You have, hang on a minute, we're getting to the height, we're talking about it. So you were on a low, very low hill that was about 35 feet above average sea level. You'll have had a tripod which will add another 4 feet to that, so we're up to nearly 40 feet. We have quite big tides in that area, and it looked like it was pretty close to low tide. I don't know. I haven't measured the tide, but it could be anything like 20 feet. So if we go for 60 feet, what we also have to do is add. So we've added an extra, say, 25 feet. You have to add some 25 feet to the hills on the opposite side as well.
So should we give it to 85? Would that be suitable for you?
No, because what you're now doing is changing the geometry, because you're adding only height to the opposite side.
All right. Are we happy with 85 feet? Is that enough for you to go with your position?
No, you're not understanding the geometry, and this is half the problem. You just don't understand simple geometry.
I'm pandering to your desire to get this as high as possible. And
I have no desire to get it as high as possible, because even at 35 feet, the fact that you've misidentified where the end of the Isle of Man is, the fact that you're looking at the Isle of Man, all we need to say is that there was greater than normal refraction, and that accounts for the observation that you saw.
So why is it that if you're allowed to say that there was greater than normal refraction and that's acceptable, when you cross-reference that with Soundly stuff and then quote, your words were, there is absolutely no evidence of refraction? So why?
No, I didn't say that. No, I said that there was no evidence that
Nathan?
on a flat surface. Can I finish? There was no evidence on a flat surface that atmospheric effects cause the curvature that Soundly has seen.
Right, Nathan. What was it that Miles actually said? Because he said it as I was coming in, so I didn't quite catch exactly what he said. But it was the thing that triggered me to come in.
I don't know. I don't want to paraphrase him either. I mean, let's just try and get through this actual example and show it.
Let me make it clear what I meant.
Probably would have been better to play it back off the other hangout.
No one has shown atmospheric effects can cause the curvature that Soundly observes at Lake Pontchartrain and at the Little Tensas Bayou.
I would argue that Soundly is the person that's demonstrated exactly that. So Soundly and Anthony Riley. Oh, you're going to talk over me continually, are you, Miles?
There is absolutely no evidence whatsoever.
Miles, I would argue that Soundly and Riley have both done exactly that. They have both demonstrated atmospherics causing what appears to be curvature. Both of them have done that, Riley and Soundly.
I have never seen anything like that.
Well, you wouldn't do, Miles. But let's go back to the.
I've never seen anyone showing curvature using any kind of atmospheric.
I've never seen anybody showing curvature either.
Me neither. Me neither. Only atmospheric conditions
effects to create the curve. People claim all kinds of blocking effects at the horizon. Oh, big deal. Yeah.
Right. So
you get mirages and you get strange mirroring effects. But not curvature.
Right, can we go back to the
which is what is observed normally.
Let's
go back to your Isle of Man.
This is where I was, but for the benefit of the people in chat, this is the height that I was at on the cliff. It says, I'll have to get rid of this now. The height was 33 feet. So I'm giving Miles whatever value he wants. I'm giving him whatever value he wants for the height. He can make it up as far as I'm concerned, because it doesn't explain the position. Now, Miles thinks it.
You carry on, Anthony. You explain why I've got it wrong. Go on.
I will do. I was just trying to get an observer height off him so we can pin him down to a particular value that he's happy with. Because
the value is irrelevant.
Right.
It really is. Well, not irrelevant, but as long as we're in the right ballpark, then
Yeah,
all you need.
as long as we're in the right.
You don't know how much refraction was there. I don't know how much.
Well, we do know that
was
refraction is
occurring on that day.
not worth calculating
We
for,
have-
don't we?
Oh man.
You say it's
on.
negligible, but you have no evidence to support that.
But I do.
None
Let's-
at all.
Let's show the evidence that I have to support it being
But
negative.
let's go for an observer height of 60 feet and
No,
a
hang
hill
on.
height on the opposite side of 325 feet.
This is Mick West recommending a paper for understanding the effects of refraction in a detailed level. It's an
Oh, for
MIT.
fuck's sake, we're not going to go back through that, are we? Sorry, Nathan.
Because this is where negligible comes from, Miles. You made the assertion I have no evidence for it, but this is an MIT paper that's recommended by
standard
Mick West.
refraction. We know that it's different on different days, and that and the next line explains that it is that when different conditions arise, then the effects become significant. So just stop trotting out that same nonsense repeatedly,
your nonsense.
because it's just nonsense.
It's your nonsense.
No, it's not my nonsense. It's nothing to do with me at all.
It's your model's nonsense, Miles. It says understand
It's nothing to do with me at all. I personally think that the standard refraction that is used
I don't care
there
what you think.
is actually
What I care about
misleading.
is what you can prove, okay? So let's go back to what it proves. So, and obviously the interpretation of the word negligible is so small or unimportant as not to be worth
For
considering.
heaven's sake, we've been
That's
through
the
this.
concept.
Can we get back to the Google Earth and the demonstration? Can we get back to the proving that, that what you're seeing is island, Anthony, instead of these definitions, please?
I'm just showing that the effects of refraction are negligible, right? So it's not even worth talking about. That's the position. Now, according to
not.
Yeah, it is. We've just been through your science very quickly. You know the position.
No, you haven't. It's
know
not
that
my science.
Refraction is negligible.
Anthony, get to the point. Prove to us that what you're seeing is island.
So the observer height was the distance in miles is 34. We're going to give him 85 feet when it was quoted as 34 or whatever. We're adding 50 feet there for whatever science Miles wants.
That's not what I asked you to do.
We're giving you whatever value you want, Miles, to make the point that you're being dishonest.
Yes, and I've told you what to do, and you've ignored it repeatedly.
I've given you 85. Would you like more?
That's not what I asked for, because that changes the
90.
geometry.
We'll give you 90.
That changes the geometry. Go for 60 feet and add 24 feet to the height on the other side, or 26 feet.
Fine.
To the height on the other side.
Right, so 60 feet, and we'll add 20 feet to the...
26 feet to the other side.
All right, so we're looking for land that is bigger than 322 feet, and if we find land that's bigger than 322 feet, the bit that's above that value will be visible according to
No. If you add the height, you are adding the height to what exists. So you are taking something which is, say, 280 feet, and you add 26 feet to that, you get 306 feet. So you then look to see if there is anything which is 280 feet above sea level at that side. And if there is, then you should be able to see it.
Right. So we'll look for values that are in excess of 280 feet, where Miles tells me...
Or thereabouts.
280.
Or thereabouts, because we don't know the refraction.
So we'll start with the coastline. We're going to be looking at the value
to interrupt,
down
Anthony.
Here, okay?
Anthony. Can I just add something? We have mean sea level.
It's not mean sea level because the tide was out.
Right, but okay, this is okay. Hold on. I've just looked it up in terms of how we get the land height, and they use mean sea level. If you want to find something that tells us that we literally adjust the height of the bloody land, then you're going to have to find a reference for that, Miles. You're going to have to.
No, I don't.
This is nonsense.
It's simple geometry.
No. It's not simple geometry. The land masses are measured and written down and documented, and they are based on mean sea level. If you can find a citation that says that we... Hold on, Miles, don't interrupt me. If you can find... Miles, don't interrupt me. Miles, I'm trying to get this out whether you like it or not. We have a standard way of measuring the height of this land. It is not done with an adjustment that you've come up with out of the top of your head. It's done using mean sea level. If you want to say that we adjust it for this measurement, I'm going to need you to find a citation, because I've done it in 20 seconds, Googled it, and found out how we get the height of this land. There's nowhere that you can find that there's an adjustment needing to be done. I'm not going to accept it. It's just nonsense.
It's nonsense.
Right, Nathan, the height of the land as measured for maps and so on requires a fixed datum point, and mean sea level is used for that. Sea level, as you know, rises up and down with the tides. That is beyond dispute. If you are looking out over a low tide, then you are looking out over a lower sea level. The height that you are above that sea is different to the height above average sea level. It is absolutely simple.
Yes, you've explained all that twice. But that's why they take an average when they give us the height of the land. Sorry, Rick, can you mute?
If you can show why it's wrong, go ahead.
I've just told you why it's wrong. They get the height of the land with a specific measure, and you're saying we need to adjust. You, as an individual, are telling us to adjust that height.
No, I'm not.
Yes, you are.
I am explaining.
That's exactly what you're doing with an explanation. I get that you've given us an explanation, Miles. But you need a citation to say where anybody else in history has physically changed the average measured height of a landmass to do this measurement. Never in history.
I am fixing that height, absolutely. What I am saying is
no, you're not. You're saying add. You've just told Anthony to add 30 feet to the height of that landmass, which is ridiculous.
Yeah.
I'm not doing that at all. Okay, so you're totally misunderstanding my point.
Okay, sorry for misunderstanding. Please explain again, Miles. Maybe I've misunderstood.
The land height remains constant. The sea level has dropped. Tide.
So we don't have to add any measurements on top of the land that we're looking at then?
Your effective height above sea level for the curve calculator is different. So
citation needed. Citation. Even my kid's getting annoyed at you, Miles. Citation is required. You can't just assert that.
As well.
You need to find a citation. You can't just assert this nonsense here. It's just nonsense.
All Miles is saying.
I get the logic, Paul. I understand the logic. He's explained it 3 times to me.
Standing on a bridge going over the water.
I get the logic, Paul. I've had it explained 3 times. Now find somewhere where someone else has applied this logic.
All he's saying is the difference between the top of the mountains and the sea level has changed. That's all Miles is saying. He hasn't asserted that the actual mountains themselves are higher. All he's
specifically
saying
told.
Is the difference between
no,
the sea
you're
level
wrong, Paul.
And the top
I've just
of the
watched him, Paul. You're wrong. I've just watched him. Told him to literally add feet to the top of a landmass. This is ridiculous.
What is on the curve calculator?
Yeah, to the height of the landmass. You've asked him to literally add a few feet onto the top of the... This is ludicrous.
Actually, you subtract from the value on the curve calculator.
Nathan, just in the spirit of moving forward, let's just give it him. But we'll not agree to it, but we'll move forward. Because the point I want to show is how he interprets the evidence. Because the evidence, the way he interprets it is ridiculous.
Well, I don't see why. Why should we slap another 30 feet on top of a landmass?
You keep saying it's ridiculous, but I'd like to see why it's ridiculous, because in multiple opportunities that I've given you, you have never once explained why.
Just explained it. They get the height using the average sea level average. They don't just say, Nathan, if you're going to make a curve calculation, what you're going to do is add a few feet onto the land that you're measuring in the distance. You find a citation for that.
No, you don't add this. You don't.
That's what you've just told him to do. You've literally told him to add height to the land he's looking at.
Anthony, can we go to your actual video of this footage
Nathan, let's just
and show where you claim that this is the end of the Isle of Man? That's the part that I would like to see.
Yeah, let's just
where you're claiming that this is the end of the Isle of Man.
Nathan, let's give way for a minute, because this is the bit where Miles is the worst in the whole... I mean, he's been bad up to now, in my opinion, and I'm sure you'd agree. But let's let the audience decide how he interprets this evidence. Is it honest, or is he totally distorting it out of the reality that it's presented with?
Okay.
And that's the latter is my position. Now, back to the globe. We're looking at the land. Miles's position is that we're not looking at Ireland in the background. We're looking at this part of Isle of Man. Now, that's possible if it lines up something like the curve calculator. Now, the curve calculator shows, let me go back to that, because you need this as the baseline. We need to have a basis on this. We're 34 miles from the Isle of Man and at 60 feet in height. Even though it says 34, we've made the adjustments that he wants us to make. There's 322 feet of reduction. We'll add the 20 feet to it, or the land, or whatever it was. We'll say this is 300, okay? So we're looking for land around about 300. And this is the area that Miles thinks that we're looking in. So we're looking down here.
Land around 280.
Well, if we can find land that's around about 300, then that means that we're possibly able to see it. 280 will give him, but for easy of just looking at it, we need to find something that's about down here, 300-ish. So we'll start with the coastline just to give people a value. 7 feet, 5 feet, 80, 50, 60, 30, 50, 40, 80, 70. So none of them are anywhere. Oh, here we go. So we've got Ramsey at 300. There's 300. So if Miles is saying that we're seeing this part here, yeah, there's some really mountains here, but these are the mountains where it stops. So this is the part where it stops. It doesn't go any further than this. So it's somewhere along here, okay? So I've just dealt with the coastline. Now we're going to deal with the land in the background. Again, we're looking for a value of around about 300-ish to give Miles any credibility whatsoever. Now, Miles found one particular point that I was unable to find, and he cherry-picked it. But if he cherry-picked it, it means that we're
not cherry-picking. You will see the highest points. So you find the highest points.
Right. Now, wherever the value was that Miles found, I mean, I'm finding nothing around the value that Miles says at 300. It's all around about 100. There was one.
Well, Anthony, I've got, hang on a second. Let me just do this. I've got 92 meters.
Well, I've got one here around about 200 feet. So this must be the point that Miles would be arguing that we could see.
No, it's not.
Well, it's the highest point I've found so far. And I'm looking across the whole landmass, Miles. I'm not being selective.
I have nearly 302 feet for one single point. So why don't we have a look at the points that I've got, Miles?
Well, just tell me the town it's near, and I'll find it.
Oh, it's near Bride.
Bride.
To the west of Bride. And there's another one to the south of Bride that gets up over 80 meters, and there's another one a little bit further west that gets over 80 meters again.
Right, so I'm in the area of Bride, and I'm looking for around about 300 feet. So I'm just getting over about 200.
Anthony, I've found these, for heaven's sake.
200. So there we go. There it is. Found it. 286. Right, there we go. So we'll put it there. Oops. So
1 feet. 302 feet nearly.
300. Right, there we go. Found the point that Miles was referring to. One little peak, right, in the whole of the landmass. Now, Miles's position is that
two others, at least two others.
At least
there's at least two others.
But we're looking at the peak of a land. Now, the point that Miles is making is that this represents the very, very summit, the very, very peak of what we're looking at. My position is clearly landmass. So
it's a small area. You're zoomed in there. It's a small area.
Can you zoom in even more?
That Miles has found one at 300 feet. But the point is, Miles is using this to say that it's the Isle of Man. Now, this is the peak of a hill. But does it match the observation or the evidence? And my assertion is that Miles is being dishonest. Where's it gone? Hang on, I've lost it. I've minimized it accidentally. So the peak of the land that Miles claims we can see, is that matching all the land that we see here? Yes. The answer is no, because we've only found one peak, Miles, and it's the absolute summit of a little hill.
No. There are three there at least, and you can show the shape of them matches almost exactly.
Now, get this. If there's three there and the shape, we're still looking at only the peak. I mean, we have to kind of guesstimate how much we're looking at here. But my position is that this is clearly more than just the summit of a hill. We're looking at significant land here. This is not consistent with what Miles is interpreting.
Yeah, you can see an incline and a decline. You can see an incline. When you zoomed in, sorry to interrupt you, Paul. When you zoomed in, you can see. Oh, you're just going to continue talking over me. You can see an incline, and you can see that it's going up and down. It's not just the peak.
Yeah, but you don't know how big it could be. It could be 50 yards across. It could be 10 yards across.
Yeah, but the thing is, though, Miles, it drops down very quickly. Within a few feet, it drops down straight away.
Yeah, but you don't know how far it's dropping. It could be dropping 3 feet.
Yeah, but Miles, we're looking at 300 feet there on the curve calculator. That's the maximum we can see.
Yeah, but you don't know how far it's dropping. Most of that hill is below the horizon.
And it's also below the point that we can see on the curve calculator.
Yeah, but that you don't know the level of refraction on that day, and some of it is
But
if
we know
you
it's
allow for the
negative, but we know where
tide.
the calculator
If you
falls.
allow for the tide, anything above about 280 feet would be visible, and that's without allowing for any unusually high refraction. And we've got no idea what the refraction is on that day.
But we know refraction
Bendy
is
light.
negligible.
I think I've got an even more valid point to make here. If you allow me to talk for about 5 or 10 minutes,
As long as you
Yeah,
can speak with
go ahead,
something
Paul.
that both of you, something that both of you aren't even considering. Anthony, can I speak for about 5 or 10 minutes now?
Go.
I'd like to share my screen, and I'd like to show something now. Something that neither of you are actually considering here.
Not at the moment.
We're still trying to get past
All right.
Miles' interpretation.
Go back to this. Okay, so I've got Google Maps up now too. I'm hoping that. Why does it do that? Okay, can you see my screen? Oh, hang on. I'm trying to think of how. I think I've shared the wrong screen. Sorry, I'll just stop sharing and I'll go back and do it again. I've got to make sure I share the right one. I think it's that one. Yeah, that's the one. All right, can you see the screen that I've got up now at the moment?
Yeah.
Yep. Okay.
It's gone away
So
again.
can see my. You'll have to click on my avatar on the bottom there, Miles, to make sure it stays up.
Yeah.
Okay. So here we've got St. Bees over here. Okay. You can see where I'm wobbling there, and here we've got the Isle of Man here.
Yeah.
And it's around about 34 miles. You agree with that, Anthony?
Sure.
It's around about 34 miles to the Isle of Man there.
Yep.
And you'll agree that I'm hoping now that I can just go between my things. Yep, here's the curvature calculator, okay? And so what we've done, we've put in, I like working in meters, but I can click on the imperial to verify that it's 60 feet in up there, okay? I've got 34 miles in there.
Sure.
Because Google Maps, what I've got there measured in metric, I'm just going to click it on metric, okay? And so it shows us that the refracted hidden here is about 98 meters, okay?
Sure.
So now I'm going to go back to Google Earth here. Okay, so what I've done is I've drawn a line, a path across the island here. I'm sure you're familiar with this. You draw the path and you find the elevations, and we can see that the Isle of Man has quite mountainous regions on this end of the island, okay, where that red arrow is going, and it has a kind of a bluff here that we see, and that I think is what you're claiming to be the end of the Isle of Man in your video. I don't want to argue about that point though. That's not the real point I'm going to try and make here, okay? And then we have the lower lying section here. You see that it gets up to about, there it's getting up to around about 72 meters. But that's not the point that I'm going to argue here, okay? What I now want to do is I want to take that off, and what I want to do is get the ruler up again, and this time I want to just use a line measurement to get a distance. So now what we're going to do is we're going to go from here, we're going to go past the Isle of Man here to Ireland, to where you think you're seeing Ireland. Obviously, you're seeing Ireland. Are you claiming? Just tell me, Anthony. Is it that direction? Is it there? Is it back here? Whereabouts are you seeing the island here?
Just line it up.
Is it around about there?
Line it up.
Let's just go to the closest.
No.
With what?
No. Line it up with the part of Isle of Man. No, yeah, there. So go.
There?
Yeah, go backwards.
There?
You'll find that there's a peak of about 2,800 feet.
And there's peaks there. That's where the peaks are, okay?
Yeah.
And so we can see that the distance measurement there is about 117 miles. I'll put that on. You agree that that's about 117 miles?
Well, I don't know. I can't see it. It's a little bit too small on my screen, but yeah, I'll go with it.
Yeah, I know it's small, but it is. You can do this yourself if you like. I'm not being dishonest here. It says 117.41 miles in there, okay? That's what it says. So what we're going to do now is we're going to go back to the Metabunk calculator, and we're going to put in 117. So I'll go back to Imperial. okay, and we'll put in just 117 miles. We'll put in 117 miles, still the same 60 feet there, blah, blah, blah. And we're going to go to metric again because I want my measurements in metric because that's what the Google Earth's on. And we see that the refracted hidden here, we're looking at 1.99 kilometres.
Yeah.
So we would expect to find 1.99 or nearly 2 kilometres. That's nearly 2,000 metres. If I go back to Imperial, we're looking for mountains that are going to have to be around about 1.23 miles.
Yeah.
Or 6,513 feet high.
Now, how high did you find the mountain?
Before they become visible. Right now, what I'm going to do is I'm going to go back. Yeah, hang on. I'm coming.
Just very quickly. Can I interrupt for just a moment?
Going to go.
Can you both just let Paul get to the end of his point?
Yeah,
He's not long got.
Please.
I'm sure.
What I'm going to do now is I'm going to go back and use my ruler again, and I'm going to do a pathway this time, and I'm going to get it to show the elevation profile as I do it. So what I'm going to do is I'm just going to put a line across here, which I can then adjust. I don't like the way it readjusts itself when I do that, okay? But what we can do here is we can see the elevation profile, and I can drag that line around to find the highest elevation. And you can see that in this area here, there's some pretty big peaks, okay? So I can move my line back here to try and get the highest elevation, okay?
Well, you need to go
and
north.
The highest elevation I'm getting there is about, well, at the moment, that's about 360 meters.
Nah, that's not what I identified in the video.
They go a lot higher than that.
There was a lot higher.
Up over
Where do they go?
That's
I know, but there's well, tell me where the highest points are.
Go northeast. Head northeast up that coast until you come to the cove.
No, the highest points are right
here?
next to where it says north 54 degrees. These are the highest peaks.
Just go northeast.
Yeah, okay. So in here somewhere.
And they're right in line as well with the Isle of Man.
Is that where you
come southeast? Come southeast, Paul.
Okay. Yeah, they're right in line with the Isle of Man, but still, I'm only seeing peaks here that are about 400 meters high.
Paul, listen.
2 kilometers
that's about
high.
right. That's about right.
Listen, Paul. No, he's not. Listen. Pull your mouse down to the southeast corner where just above the number 6. Yeah.
Here.
Right now, what?
Yeah, okay. I could wave the line around there to get a higher peak if you like. Okay, we're seeing around about 600 meters here, but we're still 1.4 kilometers off.
If you bring it nearer to the coast, Paul,
still
if you bring it nearer to the coast, you'll see that the values go significantly up. There, yeah. Now, what's the peak that you see in there? 430
I'm
meters.
only seeing 408 meters there.
Right, so go with that peak.
We're near 2 kilometers.
Go to the we've just seen 452. These are the mountains that I identified in the video.
It's only 452 meters. It doesn't matter. I can wave around here all day.
Hang on. Only 452 meters. Put that into feet. It's about 2,000 feet.
Yeah, but let's go back to the Metabunk calculator then.
Yeah, but compare that to Isle of Man, which is about 150 feet, 200 feet.
Yeah, but the thing is, Anthony, this is a greater distance. We have a higher hidden. We're expecting 6,500 feet to be hidden.
Yeah.
These mountains have to be 6,500 feet to be seen.
But that's the point.
And we're not getting
something, and neither should be visible.
Sorry to interrupt you guys. I just want to make a quick introduction because we've been joined. Sorry. Bear with me. Miles, bear with me.
Can I ask Anthony one question?
Miles. We've been joined by Ranty. How you doing, Ranty? Good to have you here.
Yeah, not too bad.
Good to have you.
Can you, Anthony, do you accept that now that we are looking, your direction of sight, your line of sight there is across above those parts of the Isle of Man that I identified?
Yes, we are looking in that angle.
Okay.
Yes, that is the right.
If you can see Ireland, why can't you see, in your view, why can't you see the Isle of Man?
Because it's flat as a pancake and significantly behind.
No, it's not flat as a pancake. There are 300-foot hills. Why?
No, it's not, Miles. You're
exaggerating. Those 300-foot hills.
Miles, you're exaggerating again. We found one peak.
No, that's a contradiction, Anthony.
Paul,
It's
shush.
a contradiction.
Paul,
If you're
shush.
claiming, no, I will not shush, because you have contradicted yourself. You're claiming that you can see mountains that should be 2 kilometres hidden below the horizon from Ireland, and yet you're saying you can't see the 300-foot hills of the Isle of Man.
Something that
Front of
perhaps
those
should be
mountains.
hidden by
Stop
no more than
speaking.
a few feet.
Paul, stop speaking. Let me speak
Yes.
to Miles. Miles, you found one peak of one hill that was around about 300 feet. The rest of the Isle of Man was below.
Taking into account the tide, there are 3 peaks that are, at least 3, that are over 300 feet above the level of the sea you were looking over.
Peak is the word, Miles.
Therefore would be visible.
But Miles, we're not looking at.
They are not sharp peaks. They are flat peaks. They are low rolling type hills.
No, they're not, Miles. They are a peak of.
Yes, they are.
Miles,
Low rolling type hills.
We're looking at land, Miles.
Yes, you are.
Right.
Yes.
So we're not looking at the peak of a hill, are we? We're looking at significant land.
You're looking. The only thing you can see is the top of those hills.
This is where you're being dishonest.
They are rolling hills, so they don't have a sharp peak.
This is where you're being dishonest,
that's
Miles.
not a problem.
I'm sorry, but we seem to have glossed completely over the point that I was making.
Yeah.
No, we haven't.
The
Miles
point
has pulled it off.
No, Anthony,
If you can see
you're
Ireland,
completely ignoring.
I haven't.
You're completely
no, Paul.
that I made.
Miles has pulled it away from it. I'm happy to deal with your point.
Not at all.
Miles has taken it away.
My question was, if you can see those peaks that should be hidden under 2 kilometers of curve, why can't you see the Isle of Man? You're saying you can't see that part of the Isle of Man. Why not?
All right, let's start with a common ground. Do we both agree, or does Paul agree as well, that both observations should be behind the curvature of the Earth? Yes or no?
No.
Right. So
no.
So let's go with the Isle of Man one then.
I'm saying I agree with Miles that the Isle of Man, you would be able to see it.
Okay, let's
but not Ireland because it's way below the curvature.
Let's disregard the island observation. Let's say that it is the Isle of Man. How is it consistent with the evidence on screen that you're looking at right now that there's one peak of one hill in the on the evidence that we may be able to see subject to refraction?
I can show you 3 or 4 peaks in that area.
Yeah, but it's defying your own rules, Miles.
I'm not defining any rules.
No, it's defying your own rules.
No, it's not.
Yes, it is, Miles, because all of it is behind the behind the curve of the Earth.
In what sense is it defying any rule?
Because it's all behind the curve of the Earth.
No, it's not.
The only bit that wouldn't be, Miles, would be the very, very peak of one of these troughs somewhere, which is not what we're seeing.
The observation height you were at, the tide height means that those should
we get to the nitty-gritty of it now, Anthony, because
no, this
we
isn't
get to the nitty-gritty of it now, Anthony, because it only takes a tiny little bit of refraction for more of those low-lying areas to be seen.
Yeah.
No, because the effects of refraction are negligible, not worth calculating.
No,
it requires a negligible amount.
Right, but the effects. Right, no. Listen, I will agree that this would be Isle of Man if it was simply the peak of one hill, but it isn't. We're seeing significant land here, so I'm not prepared to concede that this is Isle of Man.
Land do you claim to see? You're claiming that we can see something that's supposed to be 2 kilometers below the horizon?
Well, when you scale that up,
117 miles away.
What you're saying I shouldn't see, it's the same for the Isle of Man. We should not be seeing this amount of Isle of Man if it was the Isle of Man.
The point, though, Anthony, is that if you're claiming to be able to see those peaks in Ireland,
the Isle of Man.
Right, let's go back to the point.
If you're claiming to be able to see those peaks in Ireland, Anthony, then you should be able to see the entirety of the Isle of Man in front of those peaks.
Right, Paul.
There should be nothing hidden of those peaks on the Isle of Man.
Paul,
if you can see anything in Ireland, then you should see the entirety of the Isle of Man in front of those peaks.
Correct.
And yet we can't.
Yeah,
you can't.
I'm telling you, Paul.
There is
it tells you it's the Isle of Man.
No, it doesn't. It tells you that we're not seeing behind the curve, and whatever land we are seeing, if it's supposed to be the Isle of Man, it's behind the curve. We can't see it.
It tells you that we're not seeing something in front of other mountains behind them.
Oh, Snake Fell, Anthony, is over 2,000 feet, and that's on the Isle of Man.
Yeah, and we can see that clearly.
Yeah, Snake Fell. Like I say, why can't we? If you're saying that that's Ireland, why can't we see Snake Fell in front of it?
We can see Snaefell. I think you've misunderstood. We're talking. So Anthony misidentified the end of the Isle of Man in his video. So he sees Snaefell, he sees the higher hills, and he then claims that the area next to about Ramsey is the end of the Isle of Man, when in fact the Isle of Man continues for several miles beyond that.
Let's be fair. What I said was this is where the Isle of Man stops, and in relation to the evidence, that was correct.
No, it wasn't.
It was, because you couldn't see any more land after that.
No, it wasn't.
Miles, do I need to show it?
And you could see more land after that.
You say
and the land you
this is
saw
where
after
the
that
Isle of Man stops, and that's not where the Isle of Man stops.
Right. Let me show you. Look, this is what I actually said. The Isle of Man stops here. Now, I don't mean that literally. I mean it in the evidence, Miles.
Oh, you don't mean it literally. You don't mean the Isle of Man stops there. So you're agreeing that the Isle of Man continues beyond there. There is a range of hills in exactly the point where you see.
What I said was that's where the Isle of Man stops, which is what it does. It stops.
It doesn't stop. That's the point.
Miles, it does. Look.
It just doesn't stop there.
Miles, look at what happens. You can hang on.
Hey guys, I want to share my screen because this can all be cleared up very, very simply.
Right, stop. Isle of Man stops here. You can see that it stops there. That's where it stops.
No, it doesn't stop there.
That's not.
It's not the Isle of Man stopping. That's the point at which the Isle of Man is high enough for to appear above the horizon at that moment. But the part of the Isle of Man to the immediate right of that point is hidden below the curve.
So you say. But the Isle of Man stops in the evidence. There is no further evidence of the Isle of Man beyond this point. That's what I'm saying.
There
the
is.
Isle of Man stops.
And you see it. And you see it. You video it and you call it Island. It's not.
Right.
It's the Isle of Man.
But
the evidence is on your video. You're just misidentifying it.
No, but if it was the case, it would be consistent with your curve calculator, which it isn't.
It's absolutely consistent with the curve calculator.
No, Miles, it isn't, because you only found one little...
Absolutely consistent with it.
It isn't, Miles. This is where you're being dishonest.
Yes, it is. It's utterly consistent with it.
Would you describe that as a peak of a hill, Miles, or would you describe it as landmass or a cloud?
I would describe it as what's the difference between a peak of a hill and a landmass?
Well, the peak of a hill is a small triangle.
No, it's not. I'll show you. I can show you plenty of hills that do not make a triangle.
The peak is
That's ridiculous.
You're an idiot, Miles.
The apex.
You're an idiot.
No.
No, I'm
Peaks
not.
don't have to be 20. Peaks don't have to be 20.
Can you see this? Can you guys see my screen?
Yes.
If we click on it, we can. Where are we? I'm going to get the right one.
Not yet. While you're figuring that out, Miles, I'm just going to do a few links. So if you are new to this channel, or you're amongst the 50% of the people who have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live, and most importantly, if you would like to join the panel to debate anything that is being said now, simply mute the page you are currently listening to me on and click the link in the info box below this video. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you'll be ejected, and if you are, please do not try to rejoin the stream using sock accounts. If you are ejected from the stream, you will be warmly welcome back on the next stream. One more time, if you've not shared the show already, please share the show, as it does increase the live audience, which in turn increases the chances of having a more diverse panel. And again, if you've not subscribed, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. And with that, hopefully Miles has had enough time to figure out what he's going to share with us, and I'll put the screen onto Miles.
Now, this is the point where this is the second point that I have an issue with.
This is a ground view of what the Isle of Man looks like on Google.
Do it from the observation point, though, Miles. Don't do it from the middle of the.
Can't do it from the observation point.
Why is that?
because it's too small.
No, because it
and
drops
you
behind.
can't zoom in.
No, are you aware that Google Earth now accommodates for the curvature of the Earth?
Well, it always
but you
did.
can't
Let's hear you
do
say
it.
it, Miles. Just say we can't see it because the curve of the Earth is in the way. Just say it.
You can't see it.
The point
because
that
the curve of the Earth's in the way.
And,
the point that
it's
point that
too
he's making
small,
is
it's too low. Okay, so
So
When
just
you-
just
when you put
just
an
for clarity,
observer-
we're
And it
not
makes
looking
no
at this.
account for
This
refraction.
landmass isn't being seen from the same exact position because we can't
He's
look from the
cancelling the
observation
curvature
point
of
on
the Earth.
Google
Yeah.
Earth. Is that correct?
Yes, he's cancelling the curvature of the
No.
Earth by putting it in the
Right.
sea.
Hey, we've been joined by a new
What's
guest.
happening? It's a simple explanation. Can you let me explain what it is? When you put that little man there to actually what you're doing, you're looking at a human viewpoint.
No, you're not. You're
the
cancelling the
viewpoint through
curvature of the Earth.
not zoom, not the viewpoint through a zoomed camera.
You're cancelling the curvature of the
Okay.
Earth. And we can show that.
No,
If
you're
Miles
not cancelling the curve.
Oh, absolute
Yeah, he is.
rubbish.
zoom
What
into
you're
where it
doing
was,
is you're seeing a
Miles.
human viewpoint. You're not looking
Sorry,
through.
I'm trying to get there, but not doing it very efficiently.
It's okay. Just go to the point where the observation was taken, and then look at the lines. You'll see that they dip away in the distance, and that dipping away is the curve that they're accounting for. So, Miles,
Well,
You
what
have to
dip,
do it
what
from where
dip
it was.
away do you see? What dip away do you see?
look at the horizon now. Change your elevation so that you rise up slightly, so that you can see the curve.
This is the view you asked for. Okay.
Yeah, I'm asking you to
and you
change
can
your
see the
elevation.
Isle of Man there.
Miles.
These low areas.
Miles, stop.
Anthony,
Listen.
will you let me speak?
No,
because I'm
exit
presenting.
ground
I'm
level.
presenting now.
Miles,
Will
exit
you let
ground
me
level
speak?
view. Miles, look,
I
I'm
am
trying to show you that
presenting.
the curve is prominent
Anthony,
here.
he's trying to show you what you asked him to show. Let
No,
him show it.
He isn't.
So
I'm asking you to show that the lines.
Be quiet for a second.
No, Miles.
Right.
Just change your elevation, please.
Oh,
Change your elevation, please.
Miles is presenting, not you, Anthony. Let
I'm
him do his
showing that you're
presentation.
putting it in the ocean, and that's dishonest because it's.
I'm not in the ocean.
In the curve of the Earth. Please,
Not
Miles, just change
dishonest.
your elevation to about 100 feet.
No,
But you weren't 100 feet
because
above.
you weren't 100 feet above.
I'm showing you that the curve
above
of the
the
Earth
land.
is prominent on Google Earth.
Why do you want to go 100 feet above when your observation point was only 60 feet?
Yeah,
To
sorry,
show you
good
that
question,
Google Earth shows it
Paul.
behind
Sorry,
the curve of
Anthony,
the
I
Earth.
don't understand either. Why do you want him to go 100 feet above where he is? I don't get it.
Because he started off with it in the middle of the sea, and I said it was negating
I don't know how
the
to
curve.
make.
Shush.
I don't know how to make ground level view.
Just click exit
Go
ground level
100
view.
feet up.
While you guys are arguing about it, we've been joined by Mr. Flat Curve. How you doing?
Hi, how you doing,
Anthony,
Good to have you here.
look at this. Look at this image. Okay,
God's
the
sake.
Isle of Man is too small to see here in any detail at all.
Right.
In order to get,
That's not the
in
point I'm
order
trying
to get, in order to get a perspective of what the profile of the Isle of Man. I'm not claiming that this is what you would see from St. Bees at all, but in order to get a
What I'm trying to
profile of
find
the Isle of Man, Anthony, will you shut up for a second? Okay. In order to get a profile of the Isle of Man, then you need to go that you can recognize. You need to go closer, and when you go closer and look, you see exactly the profile that you got.
But the problem is, Miles, Google
It's
Earth
not a
now
problem,
is based on
and
a
I
curved
haven't
Earth.
finished speaking yet.
I know,
I'm
but you're
simply getting
misrepresenting what Google Earth is doing.
I'm not misrepresenting anything. I am being utterly clear about what I am doing and why I am doing it. And in exactly the same as I was in my video. Now, if you look from this distance, which is quite a long way away, you see exactly the profile of the Isle of Man that you saw. You see that the where you claimed the end of the Isle of Man is there. But the end of the Isle of Man is not. The end of the Isle of Man is further up here, in fact, and the low hills are here.
Yes.
And if we can get a little bit closer, and as you get closer, you can see that there are low peaks. What you saw when you zoomed in was far lower than this sort of height here. So I've got someone at my door, so I need to go. I'll leave you guys to talk about it.
Changing the rules to get a curve.
the bit I was trying to point out whilst he's answering his door, he'll probably be straight back, is that Google Earth now doesn't work on the flat plane. It's curved. So by putting it in the sea, it's
never had
negating
worked
that
on a flat plane.
Pardon?
It's always been.
Right,
It's
I'm
always
back.
worked off a curve.
No, it hasn't. That's the point. It was always flat, but recently it's now changed and it's putting things behind the curve. Didn't used to do that before. So that's why when Miles is putting it in the middle of the sea, he's negating the curve that Google Earth now does. So he has to do it from here.
No, I'm
point
showing
he's
you what the
making-
profile of the Isle of Man looks like.
Yes. Okay. Go
Okay,
on.
that's all I'm doing.
Okay. Make your point.
The closer you get, the more comes into view. Now, all we have to do now, the Google Earth will not take into account refraction. Almost certainly, it will be based purely on the calculation of the curve of the
Miles,
Earth.
let me just ask you one question.
Can I just say one thing here, please, Miles? Okay, looking at what we're seeing here, this profile that ends in the middle of the screen looks pretty much exactly like what Anthony's video says. Here is the end of the Isle of Man.
I agree.
And yet, Miles is about to demonstrate that the Isle of Man does not finish there. It continues on to the right. So go ahead, Miles.
Well, hang on. My question is, do we agree at the moment?
Go ahead,
do we agree
Miles.
that this is behind the curve? Yes or no?
Sorry? Do I agree what?
Do we agree that what you're about to show is behind the curve? Yes or no?
No.
On the maths?
No. And Anthony, can you see that at the bottom of my screen here, it's actually Google Earth is actually showing my elevation at this point as being minus 22 meters.
That's because you're in the sea.
Yeah, it's showing it as minus 22 meters. So any negating of curve, it's clearly
Miles, you're in the sea. That's why it's showing
clearly
that.
compensated.
No, it isn't
Sea
clearly
level.
compensated, Miles.
Zero should be sea level.
Miles, if you go back to the land, you will see that disappears behind the curve of the Earth. You will literally see it with your eyes.
It does not. It does not disappear behind the curve of the Earth.
Miles, do it.
We've been there.
Well, it doesn't seem to disappear behind the curve of the Earth on the photos we're seeing, Miles. I'd agree, but it does seem to do it on Google Earth.
It does.
Now, Anthony, can I challenge you again about why? Two things. Why don't you see the Isle of Man if you're looking across here? Why do you think you can see all the way to these mountains and not see either the Isle of Man here in between or the sea? Secondly, if you really thought you were onto this, and this was one of the things that riled you about my one of my comments, I think it might have been something I said in the video, but I think it was a comment. If you are seeing the island of Ireland from here, then you have made the discovery of the millennium. Okay, you have. Hang on, let me finish. You have proved, or you will have shown that in fact the Earth is not the size and shape that has been claimed for centuries. In fact, for the last 2,000 years plus. Okay, now there's a very easy way for you to take that discovery and publicize it to the world and establish it beyond any doubt. Simply go back to St. Bees and take some pictures from higher or somewhere near there and take some pictures from higher elevations. For example, on the top of this hill here somewhere. Okay, it shouldn't be too difficult to get up there and take some pictures. And when you take those pictures, you will not be able to see Ireland, and you will most definitely be able to see the Isle of Man, is my prediction.
All right, well,
but it's dead easy for you to prove. You go back there and prove that.
Let me respond.
Show that it really is Ireland, because so far, all you've done is said it can't be the Isle of Man.
You've made your point. Let me
Therefore,
respond.
it must, because of the curvature, but it must be Ireland because there is no curvature. And that doesn't make any sense.
Right, let me respond. Nathan, would you mind presenting me to everyone, please?
Yeah, you are. Yeah.
All right. So this is where I was taking the pictures from, and the answer to your question is why do I think it's one over the other? If I move out a little bit, you will see that the land in the background can be either.
I'm not seeing your screen. Hang on.
Oh, damn.
Yeah, it's okay. Just didn't present to everybody. I've got it now.
It's all right. So I'm gonna have to put the line back in because I hate how this works. I need to fix the line. Just give me a sec while I put the line back in. Something like that.
Just tell us what elevation you're at there, Anthony.
I'm just putting the line back in to make my point.
Yeah, but can you tell us what elevation it is? I can't see it on your screen.
I'm just zooming in. Hang on. Right. I'm going to save that so I don't lose it. Right. So the answer to your question is, why do I think it's one over the other? If we follow the line in and get closer and zoom in, so this is effectively going over the curve because this is what now Google Earth does. I'm going to have to zoom out a bit actually because
you can see those hills there that I identified, can't you?
You're quite right. You can see the hills.
Yeah.
But look what else you can see as you get closer.
And you can't see island behind them.
No, but you can look. Look what's
What
happening.
elevation? What elevation are you at, Anthony?
Look what.
Hold on, can you just let him get to the end of his point? You've stopped screen sharing for some reason. Oh, it looks like Anthony Riley's been sniped.
Wow.
Or well, the elevation he must have been at for that kind of image was pretty high, I would think.
Snaps again.
That was pretty interesting, actually.
I've got a group call with Ranty currently, so he can just join via that group call. So I'll be back in 30 seconds, I'd imagine.
A bunch of people got kicked. I wish these people would just keep up to date with this flat Earth debate. It'd be a lot better. That's such a catchy phrase, Nathan. You must have been so happy when you found that phrase, when you came up with it.
I've got a similar sort of view to what Anthony had, and I'm at about 700 meters above eye height of about 700 meters above sea level.
Share it.
Nearly 800, in fact.
Is that the Isle of Man?
No, it's the observation point.
Okay, and the Isle of Man, how much is it above sea level?
Well, the Isle of Man has a number of peaks and high areas and low areas. Snaefell is I forget how high, but it's quite a few hundred.
I don't have my computer.
Can you
up
see
right
that?
now.
Can you see that? So what Anthony is claiming is that I think if we follow excuse the lines all over the screen, but I've marked loads of lines on this over time. But
I'm
Anthony,
just pretending I have my artillery and I'm ready to shoot. Yeah. I'm ready to fire at Isle of Man, so I just need to see how much is above.
You might even be higher than that. I can't. I don't fiddle around with. I mean, that's at 1 kilometer height, and you can see. Now, if the Earth was flat, this is the sort of thing that I would expect to see. From Anthony's vantage point, I would expect to see all the way to Ireland. I'd be able to expect to see the Isle of Man. I'd expect to see water beyond it, and I'd expect to see Ireland in the background.
Kind of similar though.
You know, and you can't see that from a low. This is 1 kilometer above the Earth's surface. This view.
Nathan, would you present my screen again, dude?
Yeah.
Sorry.
Can you?
No worries.
Riley, can you present the bit to me where it shows your little photo? I want to see your photo, man, of what you think is Ireland or whatever's going on.
Let me just get back to the bit where I'm sharing my screen. I've got to do it on Skype, haven't I? So
I wasn't watching.
Right. So Nath, you should now have that.
You just give me 10 seconds to share it with the guys in the Hangout.
Sure.
Then I'll get it up for the public once I've done that. I always do it the other way around, and it ends up I forget to share it with the people in the Hangout. Can you guys see that in the Hangout?
Sort of. It's pretty small in the middle of the screen.
Make it a bit bigger, bear with me.
Who did the sniping this time?
No idea.
This is why we have to have this preferential treatment, you see, because when evidence comes up like this that's contentious, they simply disrupt, and there's no benefit to anybody. Just delays things by about 5 minutes while we correct.
We've got no idea who sniped who there. Absolutely.
No, I know.
Well, we know you were sniped, but we don't know who did it.
No.
It certainly wasn't me, and I'm pretty sure it wasn't Paul.
No,
I wouldn't know
it was
how
I have no
anyway.
idea how to do it.
It was YouTube or whatever his name is.
Possibly. Just we've been joined by Physics Warrior. How are you doing, Physics?
The reptiles are coming.
Say a quick hello, Physics. Can you hear us? You're on mute at the
So
moment.
the point I was trying to make was, if I was on the verge of a massive discovery,
There's a repeat.
I would
Someone's got a
immediately.
repeat.
Someone's
it
got
might
to
be me.
need to mute the sound. I would immediately be wanting to verify that, to get the next bit of evidence to back up my story. I'd want to check it out, and if I was right, I'd be, plastering it everywhere I could. And I said to Anthony that I would.
Why do you
I
think
would
I did
help
that,
him
Miles?
to get it published.
Why do you think I did that, Miles? I put it everywhere. Right, let me respond to you, Miles, with regard when I got kicked.
Everything's gone quiet for me.
I'm
Yeah.
here.
Miles,
Yeah,
let me
okay.
respond to the
But I think
previous
the point that I was trying to make is absolutely valid. If you're claiming to be able to see peaks in Ireland that are supposed to be hidden 2 kilometres below the curvature, then you should have no trouble seeing the entirety of the Isle of Man, right
Yeah, but
down
we
to
have
the
that band
waterline.
of that layer of dirty air that stops us. Do you remember that stuff that
We just don't
blocks
see that.
things out? Right, yeah. Let me deal with the first point before I got sniped. When we get the line of sight
If we
from
lost
where
Anthony
I was,
again,
pardon?
Not sure.
No,
doesn't seem
not
to
quite
be
sure
around.
what's going on.
Something strange seems to have happened to this hangout. I'm not quite sure what.
Yeah, Anthony's been
Everything
sniped.
went
Now he's come
quiet
back
for a
in on
bit.
Skype. That's it. It's easy. I've presented my screen so you can see what he's presenting on Skype.
Yeah, I don't know. But I don't know how we can argue against that.
When I look at the
just
live
about to
part
show
of the
you.
hangout, I'm actually seeing Anthony's screen.
Yeah, you see Google Earth, right?
So I'm guessing something really bizarre has happened to this.
Miles, are you able to see Google Earth right now?
And Anthony's busy presenting away.
Yeah. Can you hear me, Miles?
And we've all been sent
Yes,
to
he
some
can hear you. He's just
strange
choosing to
time
ignore
warp
you,
somewhere.
Anthony, and decided because you've come in on Skype to just ignore what you say. I don't know why, but he is. He can see you.
No, I don't
he can
think-
hear you. He's just ignoring you.
Yeah.
All right. So, make 4.
That's
Can you
pretty
see my
wacko.
screen?
I'm gonna put the sound on for the hangout.
Paul, I get your point that you should see the whole of it. I'm just wondering why you can see any of it. Sorry, I'm new to this, so.
Well, you shouldn't see,
See
any
any
of it.
of what?
The Isle of Man.
You shouldn't see any of it.
You can clearly see some of the Isle of Man. You can clearly see some of the Isle of Man from St. Bees. That's to be expected.
Okay.
No,
It's
it's
just that
not.
some parts
No, it isn't.
are usually hidden.
Yeah.
Okay.
And there's a hell of a leap. I mean, in my video where I questioned Anthony's claim that it was Ireland, I actually said all I'm showing is that he's looking over the part of the Isle of Man that he's sort of claiming isn't there. He's definitely looking over that, and it could be the Isle of Man because there are some hills of a suitable height where he sees the small bits of land poking above the horizon.
Okay, we've got to the
I
point
didn't
now
claim-
where
I
that
didn't
was what
claim
was being
he- I mean, I
discussed.
said he
That
messed
was what was
up
being
because he
discussed
did
when
mess
Anthony got sniped. So, I mean, if you want to carry on from there, Anthony, hopefully you can get it
Right.
all
Can
in.
you hear me, Nathan? Miles.
They can hear you.
Yeah, I can hear you.
Right. Great. Can you see the screen that I'm presenting with Google Earth on it?
Yes.
Right. The answer to the question, why would you think it might be Ireland, the island of Ireland? If we zoom into the line of sight, now we're seeing the island of the Isle of Man coming into the sight, like into the foreground. But look what we can also see in the background. I'm on about.
Yeah, in the foreground you can see the Isle of Man. That's the point.
That is
you
the
have
point.
to see.
And the
in
point
order to
is, now,
see Ireland
you are 34 kilometres closer.
on a flat Earth or on a curved Earth. In order to see Ireland in that location, you have to also see the Isle of Man.
No, because it's too small. Miles, look.
No,
Can you
it's
see
not too small. You've just shown
Miles.
it isn't too small.
Miles, look. Can you see in the background we have the mountain that we accept is island? Do we agree that that is island? Yeah?
Yeah.
And look
well,
at that
it's a
whopping piece
Google
of
Earth
land in front of it,
representation
it's the Isle of Man.
Yeah, and that whopping piece of land is only 70 feet tall. Okay, so let's when we
doesn't-
move
no,
it backwards,
in places it's 280
And where did
to
you have to go?
300 feet tall.
From what point of view did you have to go to see that island of Ireland?
This is what
How
I'm
high
doing.
are you on
right
that
to the
elevation?
Isle of Man.
Guys, this is what we're going to do. We're going to work backwards until the point where we can no longer see the island, not Isle of Man, island. And then you just tell me how far away it goes before you can no longer see that mountain in the background.
Yeah.
That's
How
just
high are
to
you?
do with screen resolution, Anthony.
Yeah, but the point is it lines up. So what you're saying is Isle of Man can easily be the island of Ireland because it's perfectly lined up with it. But
because you
both of them
have
are
to
supposed to
see
be behind the
both.
curve.
You can't look across. You can't look past one thing. If you're looking at two cars, one's a mile away and one's half a mile away, you can't see one, the one that's furthest away, without seeing the one in the foreground.
Miles, look, you can see that it lines up perfectly. Now I have to compensate for
Yes,
the
it
curvature
lines
of the Earth
up.
to
But if you continue that line, you'd come to, I don't know, South America or something.
Yeah, but Miles, the point is I have to compensate by
can't see
picking my
that
elevation up to see behind
And
the curve.
also, what elevation are you doing from here?
That's the point. I have to go behind the curve to see it. But I can see something in
That's
the
right.
image.
So if you're honest and go down to 60 feet again, you won't.
Right. But we see this, whatever is in the evidence, we see it without having to go up to 200 feet or whatever height it is.
You're at 60 feet.
What you see, you must see the Isle of Man, because the Isle of Man is in your eye line before Ireland.
But
So if the Earth was flat, you'd have to see it.
The point is, I'm literally on the beach here or whatever, on the cliff face or whatever. I'm not at 200 feet, and I can see this. So even if it is the Isle of Man, I haven't had to correct for the curvature, right?
And the Metabunk calculator says that anything above about 280 feet or so should definitely be visible. And with a bit of extra refraction, you could probably see anything above 250 feet. And we know there's a range of hills there that get up above that height.
Metabunk says 311 feet. And the land that we're looking at on Isle of Man, apart from one peak, is less than
But we're guessing at viewer height. We're guessing at the height of the sea, and
No,
you're not
we're not
taking into
guessing it.
account the sea height on the opposite side.
Miles, look at the land that I'm looking through. It's like this bit here is 150 feet, but this bit all the way down
Actually,
here is like
at the very least, you must accept that there is a possibility that what you have seen there could just be the Isle of Man. Furthermore, and
I
more
agree.
importantly, there is a very simple way to find out.
Miles,
Go back, take a picture from a higher elevation, and see what you see.
Miles, I can't agree that it could be the Isle of Man, but the problem is it's too low lying.
That's all I said in my video. That is all I said in my video, is it could be the Isle of Man.
About 5 minutes
No,
left.
you didn't
5
say
minutes
that,
left.
Sorry, Nath.
That
Got
is
about
what I
5
said.
minutes left to the end of this broadcast.
That isn't what you said, Miles. What you actually said was, you haven't seen Ireland at all. You've seen the Isle of Man, and you're a liar. That's what you actually said.
I don't think I referred to you as a liar in that video at all.
You always refer to me as a liar.
Other than claiming that the end of the Isle of Man was a location that it isn't. I may have referred to that as being.
In any event,
being
the
a
point
liar.
is, I don't mind it being the Isle of Man. However, most, if not all of it, is behind the curve of the Earth. The refraction
Correct,
is negligible,
and that is exactly
and
what
it
you
won't
see.
explain it. So you can pick your peak of the land if you want. And Miles, I have no problem going back and doing it for you, or for us, or for the greater good. But what happens if I come back and I see better refraction and I can see the beach the day that we go back? Let's just say, for example, that bit there, that looks like it's a cliff. What if I come back and I get the cliffs there because the refraction's in such a way that allows us to see it, and I can see this? What would your position be then?
My position would be that you've picked a day where the refraction allows you to see that.
And I would say that I've picked a day where it was just clear enough to be able to see it. So you're going to claim that if I was to see, I mean, this looks like it's the biggest point here. 250 feet.
Point there then would be to do it on multiple days.
Yeah, I was just going
And
to
see how many days you can see it.
So this 250 feet, yeah, like this bit here is probably the highest coast that we can see of it, because the rest of it looks flat. If I went back and redid the observation, and I was specifically looking for that part there because it's quite prominent, if I was to capture that, how would you feel if, given that the height is only just over 200 feet, if I could capture that in some depth, would that be enough for you to be persuasive that the Earth might not be a ball? Because that looks like it's the only bit that we would see.
I wouldn't be persuaded that the Earth is not a ball by that. I would just be persuaded that you've picked a day where refraction allows you to see that.
What if you did
and
it?
I suspect that there won't be many days where you will be able to do that.
But what happens if
unless you gain a higher elevation?
But if, let's just say that I looked for that part and I was able to locate that part, right? If I did that, you would still apply refraction to it, even though the effects are negligible, and it still should be 300 feet beyond the curve of the Earth.
Stop saying the effects are negligible. You know
Why?
that the effects can vary depending upon temperatures and all sorts of other factors.
But again,
just repeating that the effects are negligible is nonsense, because we know that we can have refraction effects anywhere between normal and extreme. Anywhere in between, Anthony.
In normal, unless we're getting fatamorganas and crazy
says
stuff, normal effects are negligible.
60 seconds
It's a
left.
nonsense, did you say?
Yes, pointing to an article saying that they're negligible is nonsense, because we know that under certain conditions,
you can't. If that's the case, then you can never point to any articles again.
Hello?
Right, clearly we can have refraction effects that are not negligible, because we see strange things.
So even if I went back and got it, you would just argue it was non-standard refraction and therefore
you're ignoring
flat.
the first part that says under standard circumstances the effects are negligible.
Yeah, and we don't get crazy refraction all the time, but it's just conveniently when it suits you because it negates the curve.
Anthony.
So basically, we're never going to be able to present evidence to you that you'll ever accept, because you'll always argue that it's non-standard refraction. Is that your position?
Flow birth. Nothing's ever good.
What about non-standard conditions? Under non-standard conditions, the effects would not be negligible.
But then we see fatamorganas and mirages and stuff, and we don't get very often.
That's right. And we do see it. We see all sorts of things, like being able to see further than we would normally be able to see.
So let me ask you, Paul, if I went back and got this leading cliff face because the refraction was kind to us and we got it, would you simply argue it was non-standard refraction and therefore the Earth was still a ball?
Absolutely, because I would
so then
want to see it
there's
done
no point in me going back then, is there?
Okay, let's do it on
standard refraction.
Paul, there would be no point in me going back, would there? Because if you're just going to argue it anyway, then there's no point.
And I think with that, I am going to say a huge, massive, enormous thank you, first and foremost, to the live audience for tuning into this debate. And of course, a massive thank you to all of the live panel for making this debate possible. Be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I will see you all in the next video.